still a lot of scripting languages or interpreted languages that are interpreted on the fly. They're not like compiled languages. They're not like high-level C or Java. They're actually going to be compiled while they're running. Because a database would send, some sort of web server would send the data to the computer, but the computer wants to generate it as fast as possible, so it runs that code on the fly. If there's an error in the code, it'll tell you after some of it's already been executed. The hardware you're going to be using, if you're in the network and telecommunications field, you're going to be using routers, switches, hubs, Ethernet, modems, basically trying to get a little network going, trying to get internet service and provide internet, provide a website, provide FTP clients and stuff like that. So what do you guys do? They develop the communication channels to the internet and provide secure service. Security service. It's working. Okay, and then the last one I got asked by Dean White to kind of mention this. This is a new field that just came up. I think last semester they started, but it wasn't official. I think this was the first time students were actually allowed to sign up for a bioengineering major, and they're going to be using the skill. They're also the beginning first, like the freshmen and sophomore. They're going to be using the same things that the ECE people use, but then they're going to be moving after junior and senior. They're going to be moving more towards bio applications to help people with disabilities or people with like amputated limbs get back on track, get like equality between the people who are kind of disabled. Or I wanted to also show you this video about deep brain stimulation, which I found very interesting since I went to some of these lectures that they had. They're going to be using software, the same OrCAD suite that electrical and computer engineers use, same MATLAB that electrical engineers use, but then they have this new thing called LabVIEW, which is it's graphical programming, which is, I'd say, is a level ahead of higher programming, higher level languages, because basically you're just going to be putting parts, defining exactly what they're going to do, little scripts on what they're going to do, and then you just run it and play with it. It's very fun to use. I was also going to show you a little simulation on this, but time and the no internet. Hardware that they're going to be using, ECG and EKG. ECG is cardiogram for the heart. EKG is, I forget what it was, but it's for the brain. And actuators basically simulate muscles. They're like they're motors that actually move up and down. They're devised specifically to replace lost limbs and to simulate like some sort of muscle, basically. They're plastic actuators, which are more like physical, and then there's motor actuators, which are more mechanical, but they both work the same way. Come on. Oh. And then the last one. This is not a major here, but unless you want to go to masters, you start going into ISA or INFS, which is ISA, I think, is Information Security and Assurance, or Information Security Architecture, and INFS is Information Forensics. Forensics more like CSI. You're going to be looking into the computer and seeing exactly what the guy was using, what the guy was doing with it. And if like some hardware was destroyed, even if someone deleted something, you're kind of going to find some tag. The data just gets, the address of the data just gets wiped out, but the data itself is still there. So you can kind of find the header files, which define like the type of file that was there that was deleted. So you'd have something like, if you deleted input.txt, you'll still have the input.txt, although some of the code might be missing, some of the writing that you wrote inside the file might be missing. You'll still find the exact folder. And there's some tools to actually refragment the data, and you can actually find out what was in there. So what do they do? Protect users from identity theft or loss of private information. Also, for companies, all their data. If it's a banking Trojan, it's just stealing banking, like all your credit card information and stuff. There's softwares that you're going to be using. Wireshark is one of the major ones I've seen lots of people use. It's kind of like a very simplistic tool. Just watch the network, see what the computer is communicating outside the computer domain. So one computer communicating with another computer communicating with the network or the internet. You can watch everything that's happening. Although nowadays it's mostly encrypted, so you have to go a little more in depth to what the program is actually doing rather than watching the network. This was developed in 1990s, and they've been using it since then, Wireshark, to kind of see what type of communications are and trying to cut off some communications that they think are malicious. Arrow Suite are usually used to crack wireless encryptions. So, of course, WEP, WPA, WPA2. PSK hasn't been cracked yet, although they're still working on it. I think there are some methods, but they're a little high-end for me. Basically, you use Arrow Suite. They cause internet interference in the network to break off client communication, so you basically lose your internet access for a brief second, and then when you're trying to recombine other people in the network that actually have the network access, they lose their connection, and then when they're trying to connect back again, you're capturing the data, you're watching their data, and you're seeing exactly what they're saying back and forth, and trying to find out what exactly the password is. You usually end up with a hash, and then you try to reverse that hash to see the exact password that you can put in, and you can get access to the same internet network. Honeypots are a very common tool, and I think the most common for this will stay on forever, because honeypots are virtual environments trapping viruses. They basically trap them in some secure environment, which is simulating like a user environment. They're simulating a computer. But the virus comes in there, it's trying to do its stuff, but you're actually monitoring exactly what it's doing. So you can kind of draw back conclusions for it, know how to protect yourself, also know exactly, the virus always has definitions. So in the end, they're going to be flagged so that, like antivirus software, they always speak to a server which has a list of definitions. If they see any of your data that has that sort of definition, they know your computer is infected. And that's how antiviruses work. Command and control are mainly to use in the hacker side of things. They're used to control viruses. Viruses spread by email, spread by going to some sites. They spread by almost every. What's the third way? They can just get spread by just the USB. Just plug it into a computer, and it's automatically in there. So the command and control, the virus code is very small code. When they go, they have to talk back to some sort of command center to get the rest of their code, to get their instructions on what they have to do next, and to like install later code. You basically plant a seed, and now you're watering it. The command and control lately it's been Twitter that's been used as a command and control center. But whatever, that's basically all the software you're going to be using. Hacker security professionals, I don't think they actually go into hardware unless they're hardware hackers, which is a completely like tinkering field. It's not actually, like, you don't actually get money, it's just for fun. It's just to see if you know mastery of the system, you can make it do things that it doesn't normally do. Get your iPhone to control your TV by making making it switch channels or increase and decrease the volume, stuff like that. So I guess this is what you're all waiting for: the money, and the average GPA as well. So these are the average GPA. I found it on Mason. Actually, I didn't put that. It's statistics, so gmu.edu has the average GPA. This is just to tell you how hard it is in Mason. If you haven't
entering or leaving.
What? This is leaving. It doesn't take into account the people who like switched majors and all that stuff. It only takes into the GPA that is accredited towards the major. So, and it's on statistics.gmu that you can check it up. But yeah, from this you can see that electrical engineers is probably the hardest major there is.
Good.
Which
The major just has to stupidest people.
probably. But this is, I think, for 5 years it's been collected data over 5 years, and I think it's constantly updating, but I don't really know. And then the rest of the stuff, the money you'll be making would probably, it's on these sites, on Indeed.com and other sources. ECE 491 is a course that students needed, that electrical and computer engineers need to take before graduation. Kind of tells you what's your how to get a future job, how to get because electrical and computer engineers don't know how to get a job by themselves. They need to have, they're too technical. When they come into the interviews, they're always like, I did this and this is how I fixed that problem and all that stuff, and they get too technical for the people that are in human resources to understand. So just it shows you how to get into graduate school, as well as how much you should be expecting to making, and how to write your resumes and all that stuff. So I got all these statistics from basically those three sources. And so the IRR department, I forget what that means, but anyway, if you just have a look at this, see that I think the security professionals are always the most paid, because usually to stay in the security professional, a hacker field, a security field, you're always going to be learning the latest techniques that viruses are using. They're always being updated. Maybe they say that every second a new malware strain is created. And I was going to show you a little slides that if I had internet access, but wow, it's almost done. It actually is done. But let's go to the just kind of specializations that we're going to go through. Electrical engineering, there's four, I guess for all the majors except bioengineering, there's 4 specializations. For electrical engineers, they're going to be working with nanotechnology, very small little bots or very small little devices. To increase efficiency. I don't know why. Every 2 years, the transistors decrease by half their size, or every year, I forget. But yeah, so if they decrease by half their size, all the components are getting half their size, basically. And solid state, very large. This VLSI is very large system. Let me see. Integrated, very large something. It's very large scale integration systems, which are basically a lot of transistors working just to protect. Just solid state design and VLSI are basically to have memory, prevent bit rot, and they're extremely fast devices. For the third one is radio frequencies. If you're a ham radio operator, you know that communications signal processing is a major issue. This is all working. This one is always working in the analog domain. It's nowhere near. They're using filters. They're using comparators, differentiators. They're all working with analog signals, never changing it to. Because when you change it to digital, you lose some of the clarity that you really need to have for radio frequency. And the RF is now used in RFIDs to tag you, and for security purposes as well. But mainly just for radio frequencies, ham radios, the thing you turn on in your car to listen to music or whatever. The fourth one, electromagnetics and antenna design. You're going to work with basically satellite dishes talking to some satellite, or you're going to be working with lasers. You're going to actually work. My